Hello, my name is Sheetal Kumari and I am doing my internship on embedded systems from Emertxe. The project is microcontroller based washing machine simulation using PicsimLab. Internship overview. Aim is to learn embedded systems development via simulation. Tools used are PicsimLab, CLCD, switches, and microcontroller. Language used is C. Key learning. Real world appliance simulation in embedded environment. Purpose. This project focuses on simulating a washing machine using PicsimLab, aiming to replicate real world washing machine functionality in virtual environment. The project begins with comprehensive understanding of washing machine components, cycles, and operations. Parameters defining laundry status such as fabric type, load size, and water level are identified. Scope. This simulation project provides valuable insights into washing machine operations, control system design, and simulation techniques to gain practical experience in applying algorithms to simulate intelligent appliances, contributing to a better understanding of laundry automation. Goals of the internship: to understand washing machine internal operations, design embedded system simulation, implement real time like behavior using PicsimLab, and apply theoretical knowledge in a hands on project. Project overview: simulation of real washing machine behavior, user interaction via virtual switches, display system states on CLCD, functional stages such as power on, program selection, water level selection, start operation, wash or rinse spin, completion status. Pixim Lab introduction to simulator for PIC microcontroller environments, supports virtual components like CLCD, buttons, buzzers, and many more. It enables testing without physical hardware. It is used to simulate real time behavior and embedded logic. Project requirements: input devices such as switch 1 for door sensor, switch 4 for navigation, switch 5 for power on or start, and switch 6 for stop. Output devices such as CLCD to display status of washing machine, buzzer to door open alert, fan for simulated washing. Design: block diagram will showing user inputs, switch 1 to switch 6, microcontroller, outputs of CLCD, buzzer, fan, board info, pick microcontroller in simulation, PicsimLab environment. This is a block diagram. Power on for switch 5, pause or stop using switch 6. For navigation, we will use switch 4. For door status, we will use switch 1. And in center, it is microcontroller. For display washing status, it will display on CLCD. buzzer, and in our project, in place of motor, we are using fan. Embedded systems brief. Definition. Hardware plus software system for a dedicated function is known as embedded system. It is used in appliances such as medical devices, cars, washing machine, and many more. Project demonstrates real-time behavior, resource limited environment, development process. To understand requirements, write C code for each screen or state, simulate using PicsimLab, test user interaction using virtual buttons. Tools used IDE, MPLab X for simulator. We are using PicsimLab, and language we have used embedded C, hardware virtually, pic board, CLCD, buzzer, buttons, implementation screens such as power on, program selection, water level menu, starter stop operations, function status, wash, range, spin, road alert, and last program completion. Now we will show demo of my project. This is a MPLab XID where I have created washing machine project, added files such as CLCD, digital keypad, main, timers, washing machine functions, and source file such as CLCD, digital keypad, ISR, main, timers, washing machine function. This is a washing machine function file where I have created power on screen function, washing machine display function, water level screen, run program, where I've also created function door status check. Set time. According to the user preference, it will start implementing the program. I have created washing program list. There is a dual options, daily, heavy, dedicates, voice, and water level such as auto, low, medium, high, max. According to the user preference, it will run. And also it's showing that build successfully. Now we will go to the PicsimLab to see the result. Here we are using PIC16 F8778 microcontroller. Now we will load the hex file, washing machine, PicsimLab. Now it's showing that press key 5 to power on washing machine. This is a simulation of an embedded washing machine system developed using the PIC16 F8778 microcontroller, written in embedded C, and tested using PicsimLab. The goal was to simulate a real-world washing machine with various washing programs, water labels, time control, starter pause features, and safety like door check. Hardware simulation components. CLCD to display washing program, water label, and time. Push buttons. Switch 4 to scroll through options. Switch 5 to start program. Switch 6 to pause program. Fan to simulate motor action. Buzzer to indicate end of washing. RB0 to simulate door status switch. Power on screen. The system shows a boot up animation when powered on. Washing program selection. User can choose from 12 present washing programs using switch 4. These are displayed on the CLCD in scrollable list. Water label selection. Next, user selects a water level, low, medium, high, or max, again using switch 4. Now, set time based on program plus label. Once program and water label are selected, time is automatically set using logic inside set time function. Start screen shows a total time. User presses switch 5 to start. Time begins. Washing phases are displayed. Wash, rinse, spin, based in progress. If we will click on switch 6, it will pause operation. And if we will click on switch 5 again, it resumes it. If we will click on RB0, then door status safety check. The machine helps with warning and resumes only when the door is closed. End of program. Once the timer reaches 0, buzzer sounds. Display notifies user to remove clothes and machine resets to initial state. The, this project demonstrates my understanding of embedded system, interrupt or timer logic, real-time simulation and how to map real-world applications into code. These are output images. Figure 1. Power on screen. It will show press key 5 to power on washing machine. Figure 2. Powering on washing machine. Figure 3. Washing program screen. It will show a 12 list we have used in our program. I have written 12 list. So according to user preferences, it will start the program. Water level program. Low, medium, high, max. User can select according to their choice. Start screen. To start the program, we will have to click switch 5, and to stop the program we have to click switch 6. Figure 6. It is a function screen. It will show wash, rinse, spin. Also it will show time. Figure 7. Door status screen. It will show door is open. Please close the door. When we will click on RB1, means switch 1. If we will click on RB0, it will show this output. Program completion status. At last it will show program completed. Remove the clothes. To this real washing machine workflow. Door check, water filling, washing cycle, rinsing cycle, spinning cycle, completion and status display. Embedded system in appliances. We can use embedded systems in to program other appliances such as microwave ovens by inserting timers and cooking logics, refrigerators by adding temperature sensors and control logic, air conditioners by adding remote, compressor or sensors. And in washing machine, we have seen wash logic, sensors, display units, and many more. Code logic overview. First, we have initialize system components, then detect button press for power on, then program and water level selection via navigation keys, then execute washing, rinsing, and spinning with delays, display appropriate messages on CLCD. The challenges I have faced is first writing modular code in embedded system, button debounce and state handling in simulation, debugging logic errors without physical feedback, and managing simulation delays and transitions. As this is my first embedded system project. Future enhancements: add real-time clock for cycle duration display, temperature control for fabric care, enhanced UI with menu navigation, cloud connected appliance simulation, IoT based. Through this project, I have learned technical embedded C programming, simulation techniques using PicsimLab, microcontroller interfacing concepts, soft skills such as debugging and testing, time management and documentation, and real world problem analysis. Conclusion: the washing machine simulation using PicsimLab served as an effective tool for learning and applying concepts in embedded systems. It offered a hands on experience that complemented theoretical knowledge and provide a foundation for further exploration in the field of automation and control systems. These are all the references I have used to make this project. First, PicsimLab documentation, second, microchip tools, then Emertxe internship resources, and embedded C programming tutorials. Thank you. From this simulation to understanding real embedded systems, this journey saved my interest in embedded systems.